In this video, we introduce more scripting concepts. Remember the use of the word go. It's important when writing scripts because sometimes you need to make sure that a statement has executed before continuing on to the next statement. Everything up to a go is considered a batch. So the go statement delimits your batches. You don't have to use a go statement at the end of the last batch at the bottom of a script. When a script finishes, SQL Server will automatically insert a go for you. Here's a common example that we use. If you are going to create a database, then you are probably going to do something with that database in the script. In order to make sure the database has been completely created and is ready for use, we put a go statement after the create database statement. Create database may take a little bit of time. Files have to be created, permissions have to be added, things like that. So we don't want to run off and try to do other things with that database until we are sure that it has been completely created. Therefore, we put a go in there after the create statement to make sure that we're ready to go. Once the go is executed, that tells SSMS, SQL Server, that that database create statement will finish before we continue on with anything else. That allows us to use the create statement against that database to create a table, knowing 100% certain that the database is there and ready to have a table created in it. Another very useful statement for us as script developers is the print statement. Sometimes we just need to communicate a message to ourselves or back to whoever our client is. There are huge numbers of clients out there, from websites to mobile devices to desktop apps. Our client is SSMS. What we do to connect to the database server is we start up SSMS, we put in the database server address on the network, and we log in with our credentials. So when we print, the information that we print goes to a tab in a window in SSMS. I'm already logged into SSMS. I can open a new query window and I can paste in the statements from the slide and I can execute them. Now there's a problem right away because the quotes on the slide are in a different font and the copy paste didn't quite give me what I wanted. This may happen to you in the future, so I'm showing it to you now. You may have to fix a quote now and then when you copy paste from some other text editor or data source into a query window. And the easy fix here is just backspace and replace that nasty incorrect quote with the proper single quote. We delimit strings in SSMS with a single quote, not with a double quote you might be used to in Java or C# or most programming languages. So this programming language uses a single quote to delimit a string, not a double quote. Now this will work. The first line of code prints hello world without the quotes. The second line of code calls a function that is built into SQL Server, getDate, which we've used before, and then prints whatever is returned from that function. We can use print in our scripts to do debugging and do communication back to ourselves when we need to know something about what the script is doing. If we knew more about our client, we could potentially send information back to the client that way too. Not done all that often, but it is an option for you as a developer. Remember that these commands, print and go, and the other commands that we'll discuss, are not case sensitive. We usually put them in uppercase, even though it looks like we're yelling. That's just because SQL is a rather old language, and it's just the tradition that we use to put the commands in uppercase. This function is also not case sensitive, but we usually put that in uppercase as well. It would not be a problem to write it like that. A little easier to read, a little modern looking if you're a programmer. Either way is fine. I probably don't have a preference. As I do things, I try to stay consistent, so I'll try to stay with uppercase, but if you find yourself preferring to write in camel case, I'm okay with that as well. Another statement, another command rather, that is available in SQL is the goto statement. We will not use it. I will tell you not to use it. There's no reason to use it. There's always a way around it. Using gotos creates something that we call spaghetti code, and battles rage online over whether it's a good idea or not. I come down squarely on the side of it not being a good idea. I will not accept it. If you use it in your assignment, it will be sent back to you for revision, and I will not use it in any examples that I write. So I stay away from the goto 100% of the time. Variables. SQL lets us create variables for use in our scripts. We use the declare statement. And then we can create a place to put information. In this case, we're creating a variable called x, and it's an integer. It's the same kind of integer that you've already seen when you create a table. All of the data types we use when we create tables are available to create variables. The @ sign is generally not pronounced. I just call this variable x. But all the variables that we will create have an @ sign in front of them, except for some temporary tables and things like that. But all the variables that you're used to when you write programs, those will all have an @ sign in front of them. That tells SQL we are creating a variable. We are not case sensitive, just like we mentioned earlier with the print statement and the go statement and the goto statement. Variables are not case sensitive in SQL. Again, I insist that you be consistent. If you declare something as a lowercase x, let's maintain that case throughout the script. If you declare it as an uppercase x, it would be the same thing as the lowercase x, but let's not go back and forth in the same script. Let's be consistent in our coding. Here's some simple variable manipulation. We create a variable called x. We make it an integer. Assigning a value to a variable is a little different than you might be used to in Java or C# or PHP or JavaScript. We use an assignment operator, yes, but we also use set. Now you will find some dialects of SQL that don't require the set. You will find different versions, but this is the way we will do it because SQL Server is happy with it, and we will live with it that way. So on the second line of this example, we assign the value 42 to our variable. Remember, we're maintaining the @ sign. In the third line of the example, we increment that variable by 1. Since it was 42, it's now 43. Then we print it. And then in the next set of statements, we actually create a more complex data type, create a variable called myDate that contains a date. So not just a number, it literally contains month, day, year, plus all the other components of a date that you're used to in SQL. And then we use the getDate function built into SQL to establish a value for that variable. Finally, we print the value of that variable. And you can see on the right, it prints 43, and it prints the date in the Messages tab of that query window. You will be declaring a lot of variables in the assignments that you write in the next couple weeks. It will be a little bit challenging to get in the habit of putting the @ sign in front of all your variables, but when you start seeing some errors, you'll figure it out. Comments. Comments are important. We want to tell ourselves, our future selves, we want to tell other people we work with what we are doing. This example is over the top because we're pretty sure we know that this is a declaration statement. We really don't need to comment the fact that it is a declaration statement. I'm just exaggerating to make a point here. Put comments in your code, explain what you're doing. You don't need to explain every individual line of code. If you like to, that's fine. But as you write more code, you will get more experience in commenting. You will develop more of a style. And then when you go to work somewhere, they may ask you to adopt a totally different style or adjust to their style. Or who knows, they may fall in love with your style. That could happen. But always be flexible and always do your best to document your code, because remember, somewhere down the road, someone else will look at it, or you will look at it in a year, 2 years, 5 years, 10 years, and you will be very happy that you tried to explain to yourself what you were up to. An important concept when dealing with variables is scope. There are times when you will use a variable and SQL will not know what it is, even though to you it looks perfectly reasonable, but for some reason you've used it out of scope. In this example, the go command terminates the scope of that variable alpha. Everything above the go and below the declare is the scope of that variable. This line of code will cause an error because alpha is out of scope and it does not exist. It simply is not in existence anymore. There's no space allocated for it anymore, and you get an error when you run the program. We'll grab this code. We run this, we get, as we saw on the slide, an error. The errors aren't too bad, they're helpful a lot of times. In this case, message 137, level 15, state 1 doesn't tell us a whole lot, but line 5 is helpful. And if we go up here and count 1, 2, 3, 4, 5, this is line 5 in the script. This is where the error took place. However, sometimes it gets a little bit longer because there are no line numbers by default in a query window. So even this may be a little useless at some points. Anyway, the point here that we're making is that this variable alpha does not exist at this point in the script. It is out of scope because the go statement terminated the scope for that variable. Now watch this. If I take out the go, I don't get the error anymore. The scope of that variable now is from the declare statement all the way to the end of the script, and the error goes away. That's probably not what I want to do to solve that problem, because I had to go in there for a reason, but it does make the error go away. We have coding standards. You will comment your code. You will make an effort to develop good habits. And one of those good habits is that the scripts you write will have comments at the top. Here is a minimum set of requirements for what I want to see in your program. I want to know your name, the course, the term, and the year, the assignment number, the date the assignment is due, and a brief one-sentence description of the assignment. This is to build good habits and get you thinking about what you're doing. And then throughout the program, I want to see comments. Again, you don't have to comment every line, but I want to see a description of what you're up to. I want you to use descriptive variable names. X, Y, and Z are generally not descriptive. use reasonable length, descriptive names that when you come back to look at your code in a year, you'll know what you were talking about. And when I look at your code and you're not sitting next to me, I will know what you're talking about. Cite your sources. If someone helps you, if you find some code online, document that in the script. Otherwise, I may consider you in violation of the code of conduct, and I may consider that your code has been plagiarized. Cite your sources. Here is a sample of the comment header that I want to see at the top of the scripts that you write. This is taken from the list of items on the previous slide: name, email, course number, assignment number, due date, and then a brief one-sentence description of what the script does or what the assignment is. We're going to launch into a discussion of tables now, and tables in scripts. If you need something to work with, you can grab this script and run it against your database on our server. Be sure that you change the use to reflect your database so it gets put in the right place. This just creates a simple pet table that we can work with. If you'd like to populate the table after you've created it, that's great. Put 2 or 3 records in it. These are the kinds of tables that we use in SQL scripts. Several of these we've already seen. The first type, standard table, we've created numerous tables. We've written views against tables. The second type, the third type, the fourth type, you use inside of a script. The fifth type is a view, which is actually a type of table. When you execute a view, it creates a results set that lives inside of a table. All of these then are considered tables. We can create a table in our script that only exists for the life of that database session. Now, a session is a little bit nebulous. We'll talk about that. But we create a temporary table by putting a pound sign in front of the table name. And that tells SQL to make a table that's going to go away probably rather quickly and will not persist in the database schema. In this case, then, we're selecting all the rows and all the columns from the pet table, and we're putting all of that information into a temporary table called ttemp pet. Now I have a pet table already. If you ran the script, then you do as well. If we execute that, the result of the select is that all 4 rows and all columns from the pet table were copied into that local temporary table that exists only for the purposes of this script, and we call that variable ttemp pet. Now I can add another statement, and I can print out what I just selected into. Now see what happens. That fails gloriously because there is already an object called #ttemp pet. And you may be thinking to yourself, well, hey, didn't we just talk about how those are temporary? Yes, they are temporary. However, they exist as long as this tab is open. For our purposes, a database session is the life of this tab. So I am going to demonstrate that by saying copy. I'm going to close the tab. And just so you trust me, I'll close the other tab. New query window. Paste. That works because by closing the query tab, we ended the session, and that caused the database engine to delete ttemppet from the database. If I run this again, it will fail because the session now is still open and ttemppet persisted from the last time I ran the script. If you get confused, then always stop and read the error message. Think about what might have happened in the script that persisted from the last time you ran the script. When in doubt, delete the whole thing. Open a new query window which creates a new session, and then just start from scratch. This is an example of what I just showed you. I have two select statements selecting into the same ttemppet temporary table. The second select statement will fail because ttemppet already exists in that session, and you can't create a table on top of an existing table. Here's a way to solve that problem besides just closing the tab. We can use a go statement. The go statement causes the drop to get executed, and the next select statement following that does not intrude on a table that's been deleted. So by inserting the go in there, the first 3 lines up here become a batch. That entire batch gets executed. It creates ttemppet. It reads the rows from ttemppet. It drops the table ttemppet. Then it executes go, which delineates the batch. The batch causes this ttemppet to go away. Remember, it goes out of scope. And then this last select statement is successful. It does not fail because there is no longer a ttemppet to interfere with this new select statement. Therefore, adding the go gave us more flexibility, and it made that drop statement work. Temporary tables are useful. Another useful strategy is what's called a table variable. And we can create a variable in a script and literally dump an entire table or an entire view into that table. Now that could get pretty scary because tables get big and you really want to think twice about storing everything in a memory variable when that everything could be hundreds or thousands of millions of records. So always give this strategy a second thought unless you know the table is small, because you really could consume resources in a bad way. Here I'm showing you then my pet table. I'm showing you 5 rows in the pet table just so you can see that there is something in the table. And here I'm declaring a variable called my pet table. Note the ampersand, the @ sign in front of the variable name. The variable, my pet table, has 2 columns. It's a table variable. Those 2 columns represent what I expect to insert into that table variable, and as a matter of fact they better be exactly what I plan to insert into that table variable. And then my insert reads from a real table in the schema tpet and populates my table variable called my pet table. Here's a more complex example. I'm creating a table that's going to have a pet and the food that pet likes to eat. So a varchar for the pet, a varchar for the pet food. That's 1 row in the table. And then I create a more complex join statement. And the result of that join statement which brings three tables together. The intermediate table is the relationship between pets and pet food. The result of that join is inserted into my table variable called my pet view. And at the bottom of this script then, I have a variable called my pet view that contains all the rows that would have been in that select statement that I have highlighted there. Again, this could get out of hand if you write a view or you do an insert into where you're referring to a significant number of records. You could be consuming a lot of resources, and this would become very inefficient to do. So use it sparingly. Be aware of what you're doing. You're creating variables which typically reside in memory, and memory is a precious resource. So this might not be something you want to do if the result of this table that you create is a very large number of rows. When I run the script from the previous slide, you can see that I get all the animals and all the pet food, all the pets and all the foods that those pets like to eat. So let's go back to the previous slide. I just backed up one, and let's grab this code. Go over it again. In the beginning of the script, we create a variable called myPetView. The variable is a table. The table has two columns. The first column is called pet. It is a varchar 50 characters wide. The second column is called pet food, is a varchar also 50 characters wide. Now I have a variable called myPetView. I'm going to insert rows into that table variable. Remember, this little guy lives in memory now. Okay, we're not creating a permanent table. We're creating a temporary table variable for use in this script only. And what gets inserted into my pet view? We're inserting pet and pet food from two different tables. Those two different tables are joined together using an intermediate table. And then when we're done, we simply print out the contents of the variable to make sure that everything worked. We run this. We get 63 rows. We can see that the bird eats beef biscuits, the butterfly eats beef biscuits. You can scroll through this and you can see who eats what. But a couple crucial points here. The structure of the table variable had better match what you're selecting into that table variable. So don't all of a sudden come up with an extra column when you do the insert into, and that extra column wasn't defined when you declared the table variable. Make sure the columns up here in the table variable match the columns you're inserting into the table down below. Thank you.